Okay, so our last method for solving linear systems is by elimination. So again, when are you going to solve, or how the different methods of solving are solving by graphing. When do you solve by graphing? Pretty much only when they tell you to. The second method is solving by substitution, and I do that when the coefficient on one of my variables is a 1. In this example, it's not a 1. This is also not one that I necessarily want to graph. So the next system, called elimination, works all the time. So if I ask you a question and I just say solve the system, and you can pick any method, this is your for sure winner. This is the one that will work all the time. So solve the system. First off, you want to make sure that your equations are both written so that the x's, the y's, and the numbers are on the same side. Not like the same side of the equation, but the same side in both. So for this one, we've got them both in semi-standard form. This one's not perfect because it's got the negative out front, but that's on purpose. So if you look at these equations, we've got our x term, we've got our y term, and on the other side of our equal sign, we have our constant. So that's step one. Step two is to transform the equations as needed so that the coefficients of one pair of variable terms are opposites. So what that means is what we've already got here. So you want one of your variables to have the same coefficient and ideally opposite signs. Not necessary, but it makes it simpler if you do. So we're going to teach it how to do it that way. So this one, we don't have to do step two because it's already done. And then the process of elimination is that you can add these equations together, and that will eliminate one of the variables. So if I look at those two equations, negative 2x plus 3y equals negative 10, and positive 2x plus 2y equals 5, and I add my two equations together, I've got negative 2x plus 2x is gone. It's 0x. Then 3y plus 2y is 5y. And then negative 10 plus 5 is negative 5. Now I'm going to solve for y by dividing both sides by 5, and I end up with y equals negative 1. That's kind of like in the substitution method, that first part is done, where you've solved for one of the variables. So step 5 is just to find the other one. So you're going to take that y equals negative 1, and you're going to plug it into one of your two equations. It doesn't matter which one. It'll work the same in both. If it doesn't, you've made a mistake. That's one way to check. So I'm going to plug it into the second equation because it's got smaller numbers. So you've got 2x plus 2y equals 5. We're going to substitute that y equals negative 1 in for y. And so you've got 2x plus 2 times negative 1 equals 5. So I've left with one variable again. So I get 2x minus 2 equals 5, so I'm going to add 2 to both sides. So I get 2x equals 7, and then I'm going to divide by 2. And there's that moment of panic when I get a fraction. I'm like, oh, maybe I did it wrong. You're allowed to get fractions in your answer. So now my guess is that my solution is 7/2 negative 1. Now maybe some of you are yelling at the screen like, are you allowed to use 3.5? You sure are. That's a great decimal to use. It doesn't matter. I just think the more often I just deal with fractions and show you dealing with fractions, by the time we get to chapter 6, you'll be like, oh, fractions, no big deal. So now if you're being great, you should be checking your solution. And again, you're just plugging it into both x and y in both equations and making sure they make them true. This one does, so my solution set is 7/2 negative 1. All right, let's work through one for scratch. So I look at this equation, these two equations, and I think, I don't want to graph these. I don't want to use that substitution, but elimination's great. I already have the same coefficient on the same variable. So your choices are, you can subtract your two equations, and that'll get rid of the variable. But I find the downside of that is that people forget whether they're adding and subtracting halfway through. So what I would do instead is I'm going to write these two equations again, but one of the equations I'm going to multiply by negative 1. So I'm going to have 4x plus 3y equals 5. I'm going to multiply this equation by negative 1. So I get negative 4x plus 7y equals negative 15. So that now I can add my two equations. So I get 4x, take away 4x is gone. I've got 3y plus 7y is 10y. And I've got 5 plus negative 15 is negative 10. Then I'm going to divide by 10 on both sides, and I get y equals negative 1. So again, I'm teaching you that you're going to always solve these equations by addition. So you're going to make sure that the coefficients have opposite signs. So potentially you're multiplying one of them by -1. If you're okay with it, you could have also subtracted the second equation. You'd get 4x minus 4x is gone, but then you have to go 3y minus -7y, which means I'm actually adding the 7y. And then you have to remember over here that you're going 5 take away 15 to get -10. So just heads up that yes, you are allowed to solve by subtraction. We just generally do a lot of them with addition because then it just keeps it consistent. But now once you've got that y equals -1, you can plug it into either equation to solve for x. So I'm going to take that top equation, 4x plus 3y equals 5. I'm going to substitute in for y with this -1, and I'm going to solve for x. So I get 4x minus 3 equals 5. I'm going to add 3 to both sides. I get 4x equals 8. Then I'm going to divide both sides by 4, and I get x equals 2. So now I'm guessing that my answer is 2, -1. Again, plug it into both equations to be sure. If you're doing your homework, you could check the back of the book, but make sure that you're right, okay? Get these right. All right, here's one. Well, actually, no, keep watching because it's got a twist. So here's one where when you look at it, I haven't given it to you. You'll notice that the x variable has a coefficient of 3 and a coefficient of 4, and the y variable has a coefficient of 2 and a coefficient of 5. So I can't just multiply one of them by -1. So instead what I have to do is multiply one or both of the equations by something so that the coefficients will be the same. So I'm going to choose to have a coefficient of 12. So I'm going to multiply this equation by +4. So I'm going to multiply this equation by +4, and I'm going to multiply this equation by -3. So I'm going to do that so I can get a +12x and a -12x. So I'm going to multiply every term by 4. So I get 12x plus 8y equals 8. Then I'm going to multiply every term by -3. I get -12x minus 15y is equal to -36. Now I can add my two equations, so 12x plus -12x is gone. 8y plus -15y is -7y, and then 8 plus -36 is -28. Then I'm going to divide both sides by -7, and I get y equals 4. Once you know that y is 4, you take that 4 and you substitute it back into one of your two equations and solve for x. I'm going to take my top equation, 3x plus 2y equals 2. I'm going to sub in for y, a 4. And I'm going to solve for x. So I get 3x plus 8 equals 2. I'm going to subtract 8. I get 3x equals -6. And I'm going to divide each side by 3, and I get x equals -2. And again, check the back of the book, plug x and y into both equations, but your solution set is -2 is your x and 4 is your y.